Hi, in this video we're going to learn how to find domain of radical and rational function. Now here we have an example and we can tell that it's a radical function because there is a square root present in our function. Now when we're finding domain, we're trying to find the values of x that is possible for this function. So first we're going to figure out where our x variable is. So in this function, our x variable is inside the square root. Now we know that when our variable is inside the square root, the variable has to be the positive numbers. It has to be greater than or equal to 0. So all the positive numbers. So now, when we have this whole expression inside our radical, we can say that 5 plus 2x has to be greater than or equal to 0. So it has to be all the positive numbers. Now let's solve for x. So subtract both sides by 5 and we got 2x greater than or equal to negative 5. And then divide both sides by 2, we got x greater than equal to negative 5 over 2. Now if we're going to state that in the interval notation, we can say that since our x is greater than or equal to negative 5 over 2, we can say, starting with the square bracket, because there's an equal to sign, so including 5 over 2, our x can be all the numbers greater than or equal to negative 5 over 2. Let's try another example. So we're going to find domain of g of x equals to square root negative x plus 3 over x. So for this function, we have our variable x inside the square root and in the denominator. So there are two restrictions for this function. The first one is that our square root can only hold positive numbers, so numbers that are greater than or equal to 0. And another restriction for this equation, for this function, is that our denominator cannot be equal to 0. So let's set up our equations. So right here, negative x plus 3, which is the expression inside our square root, has to be greater than or equal to 0. Another restriction is that our denominator, which is x, cannot be equal to 0. Alright, so let's solve for this function. So right here we have, so we're going to subtract both sides by 3. So negative x greater than or equal to negative 3. Now divide both sides by negative 1, and when we are dividing or multiplying by a negative number, we flip the inequality sign. So x becomes x less than or equal to positive 3. So now our x has to be less than or equal to 3, and it cannot be 2. It cannot be 0. So let's put that in interval notation. So starting with the negative infinity, so our x can be all the numbers from negative infinity up till 0, which it cannot be, including 0 to 3. With square bracket, because it says equal to, so our domain includes the value 3. So this is the interval notation for the domain of our g of x function. Let's try our last example. So here we have h of x equals negative x plus 3 over x squared plus 12x plus 32. So here this is a rational function, so we have a denominator in this function. So when we have a denominator, the restriction of a rational function is that the denominator cannot be equal to 0. So let's see what values of x is making our denominator equal to 0. For that, we're going to set up our denominator equal to 0. So x squared plus 12x plus 32 equals to 0. Now we need to factor it. So we can factor this function by breaking our middle term. So we can say there's x squared plus 4x plus 8x plus 32 equals to 0. So 4 times 8 is 32, which is this last term, and 4 plus 8 is 12, which is this middle term. So now try to find the common factor. X comes out, x plus 4, and then common factor in the last two terms, 8 comes out, plus 4 equals to 0. And again, common factor, plus 4. Now set each factor equals to 0. So right here, x plus 8 equals to 0. And here, x plus 4 equals to 0. Solve for x. We got x equals to negative 8. Here we got x equals to negative 4. So x cannot be negative 8 and x cannot be negative 4. Otherwise, our denominator is going to be 0. So let's state that in interval notation. So starting from the negative infinity, so our x can be negative infinity to negative 8, including negative 8 to negative 4 to negative 4 to infinity. And this is our domain for the last example. I hope that helps. Thank you for watching.